Okay, let's get right into it. We're going to look past all the headlines and really explore the raw physics and, frankly, the flawed engineering behind the Titan submersible's catastrophic failure. This is a story about material science, about unimaginable pressure, and about warnings that were just ignored.
You know, in the days after the Titan went missing, everyone was focused on something that just seemed ridiculous, right? A video game controller being used to steer the sub? And yeah, it made for a good headline, but it was a total distraction. The real fatal flaw was way more fundamental, hidden in the very materials they used to build the thing.
And that really says it all. This tragedy wasn't about cheap electronics. It was about a catastrophic misunderstanding of deep-sea physics and a really, really dangerous choice of materials. The bond between that carbon fiber tube and its titanium end caps, that was just one piece of a design that was fundamentally broken from the start.
So, to really get what went wrong, you have to look at the one thing they called an innovation, and that was its experimental carbon fiber hull, a choice that basically threw out decades of proven submersible engineering.
Okay, here's the most important thing you need to know about carbon fiber. Think of it like a rope. It's incredibly strong when you pull on it. That's called tension. But what happens when you push on a rope? It just folds. It has no strength. That's compression. And this, right here, is the central fatal mistake. An airplane uses carbon fiber to handle tension. It's keeping higher pressure inside from pushing out. The material is brilliant at that. But a deep-sea sub has to do the exact opposite. It has to withstand enormous external pressure trying to crush it. And that's compression, the one force this material is absolutely terrible at handling.
But it gets worse. There's this thing called cyclical fatigue. See, some metals can actually get stronger with use. Carbon fiber composites do the opposite. Every single dive, every time it went down and came back up, the pressure created new, invisible microcracks in the hull. It was getting permanently weaker with every single trip. This wasn't about one bad dive. It was the sum of all the damage from every dive before it.
So now let's talk about the environment this already compromised hull was going into. As the Titan sank deeper and deeper, the forces acting on it just became almost impossible to imagine. For every 33 feet you go down, the pressure increases by 1 atmosphere. That's the same pressure we feel all the time at sea level. By the time you get to the depth of the Titanic, you're looking at nearly 400 times normal atmospheric pressure. It's like having the entire weight of the Eiffel Tower balanced on a dinner plate. That translates to 5,500 pounds of force on every single square inch. To put that in perspective, imagine the weight of a big SUV, a Ford Explorer, concentrated on an area the size of a postage stamp. Now imagine that force pushing on every single inch of that hull. And this pressure isn't just there, it's an active, relentless squeeze. It's like a giant hand closing around the sub. It was literally compressing the vessel, shrinking its diameter, and putting unbelievable stress on every single fiber and, crucially, on the glue holding it all together.
Now, OceanGate's CEO, Stockton Rush, he thought he had a solution for this. He had this acoustic monitoring system that was supposed to listen for the hulls starting to fail. But the entire idea was based on a completely flawed assumption about how this material would actually break.
He actually believed they would get plenty of warning, that they'd hear the hull cracking and groaning and have all this time to get back to the surface. But he was fundamentally wrong. Metal might bend and creak and give you a warning. Composites like this, they don't give you a polite heads up. They hold, and then they just fail, instantly. And the warning signs on the surface, they were everywhere. The company that made the carbon fiber hull only certified it for a depth of 1,300 meters. That's less than a third of the way to the Titanic. An engineer was fired because he pleaded for more safety testing. Their own acoustic system had detected sounds of the layers of carbon fiber literally pulling apart on previous dives. And all of it was just dismissed. The U.S. Coast Guard later called their safety culture toxic. So you add it all up, the wrong material for the job, the accumulated damage from every previous dive, and this just unbelievable crushing pressure. It was all leading to a final moment that was as violent as it was fast. 3,800 meters. That was the depth where all those past stresses, all those design flaws, finally became too much for the hull to handle. 5,500 pounds per square inch. That was the crushing force that finally found one tiny weak point, a microcrack, a flaw in the glue, and started the chain reaction. 1,500 miles per hour. That's the estimated speed that the hull collapsed inward.
water rushed in at over 2,200 feet per second. That's literally faster than the speed of sound.
1 millisecond. From the first crack to total destruction, the entire event was over in 1,000th of a second.
Now, just to put that speed into perspective for you, it takes your brain about 100 milliseconds just to process something you see. The implosion was over before the nervous systems of anyone on board could even begin to register that anything was wrong.
And in that final brutal millisecond, another law of physics took over. As the hull was crushed, the air inside was compressed so violently and so fast that its temperature instantly flashed to a level hotter than the surface of the sun. It basically ignited. The end wasn't just a collapse, it was an instantaneous fiery. The official investigation didn't pull any punches. This wasn't some unavoidable accident. The U.S. Coast Guard concluded that this entire tragedy was the direct result of a series of safety failures and a reckless disregard for safety. It was, in their words, preventable.
Ultimately, the story of the Titan is just this devastating cautionary tale. And it leaves us with a really tough question, doesn't it? It forces us to ask where the line is between pushing boundaries and just recklessly ignoring the fundamental, unforgiving laws of physics.